We have done similar question in the last class. Please try it, okay? You guys have 6 minutes, okay? You guys have 6 minutes. आसान सवाल है. Don't need any calculation and at all. You don't need to copy the question. Start writing the answer.
सर फोर्थ वाला नहीं कर
फोर्थ वाला में इट इज क्वेश्चन ना. ऐसा लग रहा है आपने कहीं देखा ही नहीं है. फोर्थ वाले में इसने नहीं दिया है यहाँ पे वैल्यू. ठीक है, तो दैट इज व्हाई यू जस्ट हैव टू इग्नोर दैट. ओके, दैट इज नॉट नो यूज फॉर यू. Three more minutes, guys. Okay, guys, please send me whatever you have done quickly. Whatever you have done, guys, Amril, Ahmad, Abdurrahman, Fahad, Jiva, Samaira, and Zan. Please send me fast whatever you have done till now. Zan, did you watch the last lecture, Zan? Zan, please turn your mic on.
सर
Did you watch the last lecture? You were absent, na?
सर वो टाइम नहीं मिला देखने को सॉरी
नहीं तो फिर आपको नहीं समझ में आएगा, ठीक है ना? That's completely wrong. Okay.
सर मैं
You watch the lecture. अभी भूल जाइएगा, फिर भूल ही जाइएगा, ठीक है? तो उसको जल्दी जल्दी से देख के खत्म कीजिए आप लोग. Okay. Also make notes while you are watching those things. Yes, Samaira, very good. Samaira, very good. That is correct. Please send your answers, guys. Adriel, Ahmed, Abdurrahman. No. Jiva, rate law is wrong. Jiva, did you revise anything from the last lecture?
Last lecture I was not able to see the lectures.
You're not able to see. क्या मतलब not able to see?
I was not
क्यों डांट सुनना है आप लोगों को? Yeah, tell me, Jiva, what happened?
I was not having time to see it, sir.
You did not have time to see?
Yes, sir. Sorry, sir.
No. I mean, sorry का कुछ नहीं है. Don't come later, ठीक है ना? कि marks नहीं आ रहे हैं या फिर आप सर यहाँ पे हमको समझ नहीं आ रहा, वो समझ नहीं आ रहा. Now when you are having time, don't say you don't have time. Okay? Don't sleep 2 hours and watch the lectures. Okay? Don't get 8 hours of sleep. Get 6 hours of sleep, no problem. Get 4 hours of sleep one day, no problem. But watch the lecture and complete it. Now you just have one thing that you have to watch the lecture. Okay? जब एग्जाम नजदीक आएगा ना तो उस टाइम एग्जाम का प्रेशर रहेगा, ठीक है? उसके बाद आपका सिलेबस कंप्लीट नहीं रहेगा, आपका नहीं रहेगा, ठीक है? कोचिंग में कंप्लीट हो जाएगा, स्कूल में कंप्लीट हो जाएगा. दिस इज फॉर एवरीवन, दोस हु डोंट वॉच द लेक्चर आफ्टर नॉट अटेंडिंग द क्लासेस. व्हाट अबाउट अदर्स प्लीज सेंड. अब्दुल रहमान आपको बोल रहे हैं हम 5 मिनट होने वाला है. अब्दुल रहमान, उस्मान, फहद. Adriel, send whatever you have done. Abdurrahman, can you please turn your mic on?
Yes, I'm just doing all this thing.
What you are doing? You don't have to do anything. You just click the photo and send it to me. डांट क्यों सुनना है आप लोगों को?
सर लास्ट में सर
Simple
अभी
instructions.
30 बजे.
नहीं, लास्ट वास्ट कुछ नहीं. जो है आप भेजिए ना, आप मार्क्स मिल जाएंगे आपको. यहाँ पे बोर्ड्स में 5 नंबर एक्स्ट्रा आ जाएगा. डांट क्यों सुनना आप लोगों को? आप जितना भी कर रहे हैं हमको समझ में आ जाएगा ना, आप सही जा रहे हैं नहीं जा रहे हैं, कहाँ तक जाइए. आपको भेजने जब बोला जा रहा है आप भेजिए तुरंत. Yeah, Fahad, I mean, your approach is right and all of these things are correct. थोड़ा terms को किस तरह से लिखना है उस पर थोड़ा वर्क करना पड़ेगा, otherwise everything is fine. Value of k We'll have to see the value of K actually. I mean, the value of K, no, that's not right actually. The value of K is not right. Otherwise, I think it is fine. है ना? चारों के reactions are ठीक है चलिए. Okay, Ahmed, you're doing fine. But yeah, that's fine, Abdul Rahman. जहाँ तक आपने किया है. नहीं, wait a second. X आपने किसको लिया है? NO की power X लिया है आपने. No, then that is not right. ठीक है? The thing is that you all want, ठीक है, you just take note of the time, how much time it is taking. What you need to do, first of all, you need to write all of these three in terms of equation. My rate law will be equal to K into NO to the power of X and chlorine to the power of Y. Then I need to write the first experiment. The first experiment says that initial rate of disappearance of Cl2 is what? 0.60 is equal to the constant K. Concentration of NO is 0.15 to the power of X, and then we have chlorine to the power of Y. Chlorine and concentration of chlorine is how much? 0.15. 1.20 is equal to K. Concentration is 0.1 power of X. Then we have 0.30 to the power of Y. Third is 2.40, which is equal to K. The concentration of NO is 0.30. Concentration of Cl is 0.15. This is to the power X, this is to the power Y. Now, first of all, we'll see. I can take equation 1 and 2. So I will do 2 divided by 1 because 2 is greater. आसानी के लिए. So for 2, I will write 1.20 divided by 0.60 will be equal to K 0.15 to the power of X, 0.30 to the power of Y, divided by K 0.15 to the power X, 0.15 to the power Y. Okay, now this will get cancelled by 2, right? And then K will be getting cancelled. 0.15 to the power X, 0.15 to the power X will be getting cancelled. I will get 2 is equal to 0.30 divided by 0.15 to the power of whole to the power of Y. This is going to get cancelled by 2. 0.15 into 2 will be equal to 0.30. And then I will get 2 to the power 1 is equal to 2 to the power of Y. Hence, I can say Y it is equal to 1. Okay, Y is equal to 1. Next thing is that we can divide which equations in which Y is same. I can divide 1 and 3. So 3 divided by 1. So 3 is 2.40 divided by 0.60 is equal to K 0.30 to the power of X, 0.15 to the power of Y divided by K 0.15 to the power of X, 0.15 to the power of Y. Now Y and Y will getting cancelled, K will get cancelled, 0.60, 4s are 2.40. Now I will get this as 2 to the power of 2 is equal to 0.30 divided by 0.15 to the power of X. I can write this as 2 to the power of 2 is equal to 2 to the power of X, and hence X will be equal to 2. Okay. Now, how much time did it take? 3 minutes, less than 3 minutes. Okay. It took less than 3 minutes to get the rate equation. Now, what you need to do, you need to just calculate the value of rate constant and specify its unit. First of all, what is the order? Order is equal to 2 plus 1 is equal to 3. Now, unit of rate constant वो देख लेंगे बाद में, but now what is the rate constant? K will be equal to the rate divided by concentration of NO to the power X and concentration of chlorine to the power of Y. Let us take a easy case. I think the first one will be the easiest. Yeah. So rate will be equal to 0.60. divided by 0.15 square and 0.15. This will be equal to 0.60 divided by, I can cancel this by 4za, right? Right. I can cancel this by 4za, and then in here I'm going to have, this is just 4, and then we are going to have 0.15 plus square. Okay, so 4 upon 0.15 square will be how much? Tell me. 15 square is equal to how much?
0.0225.
0.0225. ठीक है, so, अगर यहाँ तक भी आप लोग करते ना, that would have been fine. लेकिन किसी का मतलब like those who have got the rate at least, okay, that's fine. अगर आप लोगों को कम से कम ये मिल गया कि y is equal to इतना है, x is equal to इतना है, then you can write the rate is equal to k into the concentration of NO to the power of 2 and chlorine to the power of 1. वो बहुत ही ज़्यादा simple था. Now another thing is that I have also told you guys that there is a very easy way to doing that. This is if you want to give all the explanation, full explanation. लेकिन अगर आपको जल्दी करना था भैया ना, आप लोग रिवाइज करके रखते अगर, तो आप लोग को पता होता, राइट? अगर आप लोग रिवाइज करके रखते तो क्या बोला था हमने इन द लास्ट क्लास? आई सेड दैट if you want to calculate what, if you want to calculate x, look at the one where y is common. Where is y common? I can say that in 1 and 3 the y is common, so you will ignore the y and write everything else. ठीक है, तो 0.24 upon 0.6 is equal to k. 24 में क्या है? 0.30 to the power x, and here we are having 0.15 to the power of x. Okay, now you can easily see that 0.15 and 0.30, they are having a relationship of what? They're having a relationship of 2 to the power of x, right? And here we are having 4, so 4 is equal to 2 to the power x, and then you can directly write it. But why? You will understand this when you have revised anything, but since you guys do not revise, please write it down. Please write it down. Actually, before that, let me also write the unit of rate constant. Unit will be equal to, what did we say? Order is equal to power of L plus 1. Power of L plus 1. Okay, now that means if I want to write the power of L, it will be what? Order minus 1. Order is 3, so the power of L will be what? 2. L square. Mole has the same unit, but sign changes and second inverse. This is going to be your unit. Okay. जल्दी लिखिएगा इसको. This will come out to be 177.78 meter square. Mole minus 2, second inverse. Adriel, I think you got it correct, right, Adriel?
Yes, sir.
I hope.
I got one. Yeah, same thing.
हाँ नहीं, like I hope you have taken Cl2 as y, and for the power of NO you have taken it as x.
Yes, yes.
Done everyone? Yes or no? Please tell me.
Yes, sir.
No, it is Fahad हमने बताया 177.78 होगा. Or it will be 177.78. Okay. Write the topic molecularity of a reaction. Last class में calculator. Please write. What is molecularity of reaction? The number of molecules or atoms or ions that collide in an elementary reaction is called molecularity of reaction. For example, if I have a molecule, if I have an atom A and atom B, in a single step this reaction happens and it is going to give me product B. So for this we are going to write molecularity is equal to, so there are A and B, there are two atoms which are going to collide, so this will be what? Molecularity will be 2. Molecularity for this reaction is going to be 2. You can also write number of molecules or atoms or ions colliding to form products. Now let us see a question in which you will understand what is the difference and what is the difference between order and molecularity. Please write this question. Write this, and first of all, you all will send me in chat what is the order of reaction. Send me in chat what is the order of reaction. Yes, Ahmed, correct. Yes, Adil, correct. Very good. Yes, Abdul Rahman, very good, correct. Anyone else? Order of reaction, Samaira, Sahel, Maimuna. For this, we are going to write the rate of reaction as rate is equal to K into the concentration of NH3 to the power of X. Okay, to the power of X. Now this is my thought that this should be, now we have to determine what is X. Why you have to determine what is X? We have already been given the rate of reaction and they are saying that this is equal to K. This can be equal to K only and only when X is equal to how much? Please tell me, guys. Mamuna, Samaira, please turn your mic on and tell me. X should be equal to how much? If this is equal to K. Yes, Mamuna. जल्दी बताइए मैमुना, x की वैल्यू क्या होनी चाहिए अगर k के बराबर करना है तो? Samaira, what do you think?
0.
0, correct. Mamuna, you can't turn your mic on. Or is she not here? Achha. Please rejoin, Mamuna, please rejoin. Okay, x will be 0. That means the order of this reaction is equal to zero. Okay. Now, what is the molecularity of this reaction? There are 2 moles of NH3. There are 2 moles of NH3 which are colliding, and that is why the molecularity will be equal to molecularity is equal to 2. Okay. Now the unit of K will be what? Order is equal to 0. So the unit of K will be what? Tell me, guys. It will be the same as whatever the order of rate, whatever the unit of rate is. Moles per liter second inverse. Okay. If you have order, just remember power of L is equal to order minus 1. Okay, so power of L or is liter to the power minus 1. Mole will have the same power but with opposite sign. So mole ke paas +1 and second inverse is constant in all of the orders. Okay, so I hope all of you understood what is the difference between order and the molecularity of a reaction. Yes or no, guys? Please tell me.
So can you explain molecularity once again?
You have the number of atoms which are going to collide to make the product. That is the molecularity. Here there are 2 NH3 molecules which are colliding. Then only we are going to get the product. That is why this is the molecularity. 2 is the molecularity. That means we need 2 molecules for the formation of product. Got it?
Yes, sir.
Okay. Right, next. Types of reaction. Types of reactions. Now, all the chemical reactions, they can be classified into 2 categories. Their reaction, which are going to be single step reaction, multi-step reaction. Okay. Now, this single step reaction, these are known as, please remember, elementary reactions. Okay, if you have one step, that is going to be elementary reaction. Please write. Product is formed. Please write this with me, okay? Product is formed in a single step. Product is formed in a single step. For example, we have NH4, NO2, and when you are going to heat it, it is going to give you nitrogen gas and 2 moles of H2O. Now, in this case, as you can see, we need only 1 molecule for the formation of product. That is why the molecularity is going to be 1. Then another reaction you can take, for example, 2HI. It is going to give H2 plus I2. In this case, the molecularity is equal to 2. You can have another situation, 2NO plus O2. This is going to give you 2 moles of NO2. In this case, the molecularity is going to be 3. Okay. So when you have molecularity is equal to 1, these reactions are known as unimolecular reactions. Unimolecular. If molecularity is equal to 2, these are known as bimolecular. And when the molecularity is equal to 3, these are known as termolecular. Now, the most common reactions are bimolecular reactions, and also termolecular reactions are also, they do happen, but molecularity more than 4 is very rare. Why it is very rare? See, when there are 4 atoms, please look here, don't write now, please look here. When there are 4 atoms which are going to collide with each other. So we have 1 atom, 2 atom, 3 atom, and 4 atom. These are colliding with each other, but as you can see, the green ones are colliding with each other, right? All of these are colliding with each other, but the diagonal ones are not colliding with each other. Yes or no? Can all of you see that? Yes or no? Please tell me, guys. The
Yes, sir.
diagonal ones are not colliding. है ना? That is why the molecularity cannot be 4. I mean, it's very, very rare. और वो कब होगा? See, there is only one orientation of the molecules which will give you the molecularity 4. When you have 3 atoms like this in one plane, and there is another 4th atom which is coming from either above or below. So if you have this kind of orientation and the collision is taking place in this type, then you are going to get a molecularity of 4. But again, this type of orientation is very difficult to get randomly. Okay, so random इस तरह का arrangement बहुत ही मुश्किल से मिलता है. Now, next is multi-step reaction. Okay, so multi-step reaction, these are known as complex reactions. Complex reactions. Please write here. Product is formed in more than one step. And each of these steps, okay, अब मान लीजिए 5 स्टेप है, तो 5 स्टेप में से पहला स्टेप भी it is single step, so that is why it is going to be elementary. Each of those steps are going to be elementary reactions. Okay, please write each of those steps are elementary reaction. Okay, let's look at an example. For example, we have a reaction in which 2 moles of H2O2, it dissociates into 2 moles of H2O and 1 mole of oxygen gas. Now in this, the step 1 is going to be H2O2. It gives you H2O2 gives you H2O molecule and 1 nascent oxygen atom. Another H2O2, it gives you H2O and another oxygen atom. In step 2, we have 2 nascent oxygens, which gives you O2. And overall, you can see that here we have 2 H2O2 giving you 2 H2O plus O2. Okay. Why? Because this O and O, this can be cancelled when I'm going to add it, because 2 O's are in product and then we have 2 O in the reactant. So they are going to cancel each other. In step 1, the molecularity is equal to 1. Step this also H2O, molecularity is equal to 1. But for this step, the molecularity it is equal to 2. There are 2 nascent oxygen which are colliding with each other to get oxygen gas. Okay, so molecularity it is equal to 2. Please write this down, guys. Copy this down. Let me know when you're done.
So in the first step, is it H2O2?
Sorry.
In the first step, is it H2O2?
हाँ H2O2 है ये दोनों में. both of these are H2O2. Please let me know when you're done, guys.
Done, sir.
Yes, then that is getting cancelled because equation की तरह होता है. These are chemical equations ना. आप दो इक्वेशन को अगर ऐड कर रहे हैं इस तरह से 2a is equal to c and let us say d is equal to c, or rather you're writing here, and c is equal to d, तो c और c कैंसिल हो जाता है. 2a is equal to d, है ना. तो इक्वालिटी साइन नहीं होता केमिकल इक्वेशन में. दीज आर इक्वेशंस, लेकिन प्लीज याद रखिए, ठीक है. दीज आर केमिकल इक्वेशंस, बट अगेन जो इसका अरिथमेटिक है दैट इज गोइंग टू बी सिमिलर टू मैथमेटिकल इक्वेशंस. इसी वजह से जब मल्टीप्लाई करते हैं तो रिएक्टेंट और प्रोडक्ट दोनों तरफ मल्टीप्लाई होता है, LHS RHS. ओके, चलिए नाउ कॉपी दिस डाउन. प्लीज कॉपी दिस डाउन. There are 6 points. Please let me know if you don't understand any one of the points. We have already discussed all of the points. Number of reacting species undergoing simultaneous condition in elementary or simple reaction. Molecularity is applicable for elementary and for complex reaction. For complex reaction, molecularity has no meaning. ठीक है, अगर सिंगल स्टेप में जो चीज हो रही है बस वही के लिए होता है. फॉर एग्जाम्पल अगर यहाँ की बात करें, इसके लिए हम लोग मॉलिक्युलरिटी की कोई मतलब नहीं है. मॉलिक्युलरिटी इज नथिंग फॉर दिस रिएक्शन बिकॉज H2H2 2H2O2 giving 2H2, this is a complex reaction. ठीक है, if it is single step, all the elementary reactions will have molecularity, nothing else. Please write this down, complete this. लिख लिया आप लोगों ने SNOP में गाइस? Yes, Sahel, Jiva, Fahad, Abdurrahman, done? Still writing?
No, sir.
No, not done. लिखिए जल्दी लिखिए. Write sentence by sentence, word by word मत लिखा कीजिए. Read the complete sentence and try to write the complete sentence. Done guys? नहीं हुआ अभी तक? जल्दी लिखिए. Okay. चलिए. Is there anyone who is still writing? Anyone who is still writing? Please say fast yes or no. No. Okay, everyone is done. Please write. Determine the rate law for the following. Whenever they are saying determine the rate law, they indirectly mean that you have to determine the order of reaction. What we have to determine? We have to determine the order of reaction. Okay, so this is one of the equations that you must have seen in the chemical. Sorry, you must have seen this in organic chemistry. Okay, in halori. So let us suppose we have a reaction like this, in which we have a benzyl halide. This is not a halorine. This is what's sp3 carbon. That is why it is benzyl halide plus aqueous NaOH is going to give you benzyl alcohol. We will not get phenol. We will get alcohol because this is haloalkane. OH plus sodium iodide. Now, since we are having a benzene ring here and then there is a carbon atom, this can be easily done via SN1 reaction. Okay, so step 1 of SN1 reaction is what? Formation of carbocation. Formation of carbocation. And this I will leave, and it is going to give you CH2 positive plus I negative. Now this CH2 positive is resonance stabilized. That is why this is undergoing through. This is happening via SN1. In step 2, what happens? In step 2, we have CH2 positive from NaOH, OH negative with its lone pair electrons and the negative charge will attack on the carbon atom and giving the formation of benzyl alcohol. Okay, now first thing is that we have to determine which is the slowest step. Slowest step is going to determine the rate law. It is going to determine the order of reaction. Please write in chat, guys. What do you think is the slowest step? Step 1 or step 2, which is going to be slow? Which of this is slowest? Yes, Adriel, correct. Very good. Very good, Abdurrahman, correct. Which is the slowest step? Samaira, very good, correct. Yes, Jiva, very good, correct. Yes, Abdurrahman, correct. Okay. Also, please remember, शायद आप लोग भूल गए हो कि why it is going to be slow. Please listen, guys. This is a neutral species, and this is a charged species. So neutral is going to be stable. Charge is always going to be unstable if I compare it with neutral. So when we are going from stable to unstable, that is going to be slow. And this is what positive and negative, they will quickly attract itself and it will be very fast. Okay, positive charge and negative charge, they are going to attract each other. यहाँ पे bond breaking हो रहा है, that's why it is going to be slow. Okay, that's why it is going to be slow. Now, if this is my slowest step, then the rate will be determined by this step only, because even if this step is faster, all the rate is going to be determined by the slowest step. Let's say, for example, those who are new, you can rely on this analogy here. Okay, let's suppose there is a computer manufacturing unit, and in computer manufacturing unit, we have different departments. Okay, we have different departments. Let's suppose we have the CPU department. Okay, then we have the monitor, the keyboard, and the mouse. Okay, and then we have the software installation, whatever they do, software installation. Okay, now let us suppose that CPU manufacturing takes in single day, it can manufacture only 50 CPUs. Monitor and this, they can manufacture 200. Software installation, it can be done for 1000 laptops at a single time. लेकिन अगर आप ये देखिए तो maximum, the maximum number of PC that can be produced in a day, बताइए कितने PC प्रोड्यूस हो सकते हैं एक दिन में मैक्सिमम? If CPU is giving 50 per day, okay, monitor, keyboard, and mouses, you can produce 200 units per day. Software you can do for 1000 units. So maximum number of PCs कितना ये हो सकता है, बन सकता है? Tell me, guys, what do you think? What is the maximum number of PC you can produce in a day if this is the logistics? Yes, Zan, correct. So Zan, can you see now? You can see now, slowest step is going to determine the rate of production of PCs, correct? Zan? Can you see that, Zan? Anna, what about others? Tell me, what is the maximum number of PCs that can be produced in a day? Okay, Adil, I'm just letting you know. Let's suppose we have a computer manufacturing, some warehouse or some factory, and in that they can manufacture 50 CPUs in a day. They can manufacture 200 units of monitor, keyboard, and mouse as a full stack in a day, and they can do software installation in a laptop, 1000 per day. Okay, software installation can be done 1000 per day. I'm asking what is the maximum number of PC that can be produced in a day, if this is the logistics. Maximum number of PCs that can be produced in a day. What about others? Fahad, Abdurrahman, Sahal, Maimuna, Samaira, please answer, guys. Yes, Adriel, correct, very good. Please answer, guys. मुंह तो खोलिए आप लोग तो जवाब ही नहीं देते हैं बिल्कुल. Fahad, what do you think? Fahad, turn your mic on. Fahad, what do you think? Fahad, I'm asking to turn your mic on.
Yes, sir.
What do you think? What is the maximum number of PCs that can be produced in a day? फिजिकली ये 3 चीज चाहिए, सीपीयू चाहिए, मॉनिटर, कीबोर्ड और माउस चाहिए, और सॉफ्टवेयर चाहिए। ओके, कोई आइडिया नहीं? 1000? अरे भाई जब 50 ही सीपीयू बनेंगे तो 1000 कहाँ से बनाइएगा आप? बिना सीपीयू के बन जाएगा? हाँ फहद, ये तो स्लोवेस्ट स्टेप है ना, 50 से ज्यादा आप बना ही नहीं सकते, है ना? अब भले ही 200 आप बना के रख लीजिए माउस, मॉनिटर, कीबोर्ड, लेकिन आप 200 के क्या कीजिएगा उनका? सीपीयू नहीं है तो, राइट? So what is the maximum? The slowest step is going to determine the rate of production. Similarly,
So
here
50.
also the slowest step is going to determine the rate of the reaction. Okay, please write. Rate is determined by the slowest step in the reaction mechanism. Okay, in the reaction mechanism. Let us suppose this is my A, this is my B. So for this case, the rate will be equal to the rate constant K into the concentration of A, because 1 mole of A is going to is being used to get the products. Okay, this is the slowest step. B has no role in the rate of reaction. B has no role in the rate of reaction. लेकिन क्या B के बिना, please listen, लेकिन क्या B के बिना reaction होगा? नहीं होगा. For example, this software installation has no role in the production of, in the rate of production of computers, in the rate of production. कितना तेजी से हो रहा है? That software does not have any role in that. If you are going to increase the software production to 2000, then still the rate of production is going to be 50 per day, right? Now, in this case, the rate is dependent completely on the CPU production. If you are going to increase the CPU production, then only the rate is going to increase. Similarly here, if you are going to increase the concentration of A, only and only then the rate is going to increase. It doesn't matter how much the concentration of B is present. All of you understood this point? Yes or no? Please tell me, guys. Understood this? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Okay, right, next. It's very important. The order of a complex reaction is equal to molecularity of its rate determining step, that is RDS. Okay, that is RDS. Let's suppose you have given a reaction like this, and they've also given you the mechanism of the reaction. Okay. So there are 2 steps in this mechanism. This is the first step. This is the second step. Okay, this is the second step. So tell me, rate will be determined by which step? Step 1 or step 2?
Step one.
Step one.
Guys.
Step one.
So rate will be determined by RDS is step 1. And what is the molecularity of step 1? Yeah, very good. Molecularity of step 1 is equal to 2. That is why the order of this reaction will be what? इस reaction का order क्या हो जाएगा? See, order of a complex reaction. ये complex reaction, because it is multi-step, is equal to the molecularity of redetermining step. Redetermining step is step 1, उसकी molecularity 2. That is why the order of this complete reaction is going to be 2. ठीक है, इस reaction का order क्या हो जाएगा? 2 हो जाएगा. Okay, there's another reaction like this. Okay. Tell me what is the order of this reaction? No, no. Samaira correct. Ahmed, no, not correct. Ahmed, please देखिए ठीक से Ahmed. First of all, determine the RDS, then determine the molecularity of the RDS, and then that is going to be the order of reaction. Oh my God, Huzafa is अभी दिया है. No, Abdul Rahman wrong. What is the RDS? RDS आप लोग नहीं देख पा रहे हैं क्या? Redetermining step तो देखिए, उसमें क्या है molecularity उसकी? Yes, Fahad correct. हाँ, अब्दुल रहमान अब सही है. पता नहीं क्या देखते हैं आप लोग, इसमें मिस्टेक कर रहे हैं. सिंपल सा सवाल, ना कुछ कैलकुलेशन है ना कुछ. ये सहल करेक्ट. Mamuna, I'm not getting any answers from you. Why? Yes, Mamuna, correct. Very good. See, the RDS is the slowest step. That is going to be step 1. The molecularity of step 1 is equal to 1 because it is only one molecule of N2O5, and that is why the order of the complete reaction is going to be 1. Yes, Jiva correct, Ahmed correct. Okay, let us now move on. And now let us just take a few moments, okay, and understand whatever we have done till now. We are going to learn about the rate of reaction. We are going to learn about the rate of reaction, and we have seen rate of reaction in 2 different ways. We have seen the rate equation, the rate of a reaction. And for this rate of reaction, we need to do the experiment and we need to monitor the experiment. Then only we can tell about the change in the concentration of the reactant molecule divided by the change in time. Now, for this type of rate, if you want to determine the rate of reaction using this particular equation, what you need to do, we need to monitor the reaction. You need to do the reaction and then monitor it. And let us suppose the another way is what? The another way is, let's suppose that reaction has already been done and people has already figured out what is the rate law equation. So you can determine the rate will be equal to the concentration of K to the power of A to the power of X. Okay. So from here also you can determine the rate. From here also we can determine the rate. So this second one, it does not require any experiment from our side. Many people, they will do the experiment and they have already determined the rate of reaction for many different reactions. So this does not require experiment. This does not require experiment. Okay. Achha. Now, if I look at this rate law equation, because obviously, please remember that you don't want to do the experiment always. Okay. We do the chemicals, these things are expensive. And if you know that the rate of reaction is going to be very slow, then you don't do that reaction. है ना, ऐसा नहीं कि हर reaction के लिए हम लोग क्या करेंगे, experiment लगा देंगे and then we will be just monitoring that particular reaction. That is not a very good idea. That is not very feasible economically also. Okay, that's not logical also. If you know the rate, now most of the reaction that you are going to see and most of the reaction that people work on, they have already been worked before and everyone knows what is the rate law equation for that. But the problem with the rate law equation is that this rate is dependent on the concentration of reactant. But please remember, as the time, this is my time, and this is the concentration of my reactant molecule. The concentration of my reactant molecule is going to decrease. For example, if the rate of reaction is just like order of 1, then it is going to decrease linearly. If it is order 2, then it is going to decrease somewhat like this. If it is order 3, then it is going to decrease more, and it is going to have more slope. It is going to be more curved. It is 4, then it is going to have more curve. That means it is going to decrease more fastly. Okay, if the order is increasing, then the concentration of the reactant molecule is going to decrease more fastly. Now that is proven. Now, when the concentration of this reactant molecule will decrease, then the rate will also decrease. That means rate is not a constant. Rate is always changing. If the reaction has happened for a very small period of time, for a moment also, if the reaction has happened, the concentration of A will decrease. And when the concentration of A decreases, the rate of reaction is going to decrease. Then again, the concentration of A will decrease, the rate of reaction is going to decrease. Okay, then there again. Now you can see that this is going to happen until and unless the reaction is completely done. So this rate law equation is not of very much use as of now. It is not of very much use as of now, because the rate of the concentration of A is always going to decrease. कोई constant तो नहीं रहेगा ना. Like if you are taking 5 moles per liter, 5 molar, then हमेशा ये 5 molar नहीं रहेगा, ये धीरे धीरे कम होता जाएगा, और जैसे जैसे ये कम होता जाएगा, the rate is also going to decrease. तो हम लोग ये कभी पता ही नहीं लगा पाएंगे कि कितने टाइम के बाद रिएक्शन कंप्लीट होगा. Okay, how much time is it going to take to complete the reaction? We can never tell by this particular equation. We can never tell by this particular equation. और यहाँ पे कोई time का, we don't have anything, any term for time here also. Okay, so this is of no use as of now. Now, when you have something which is always changing, then we can work around it using what? We can work around it using the small change that is represented by D, and the overall change that is going to happen, we can calculate by doing integration. And that is why we have the integrated rate law equations or integrated rate law expressions, which help us to determine if I give some initial concentration of reactant. If I give the initial concentration of reactant, I know the rate constant because this reaction has already been done by many people, And then let us suppose I need some final, I give it some final concentration of the reactant. Then how much time is it going to take? The time taken by the reaction. Okay, if I give it initial condition and the final condition, then I can determine just with pen and paper, without doing the experiment, without monitoring the experiment, how much time is it going to take to complete the reaction, And for this, what do we have? The integrated rate law equation. Please remember, integrated rate law equation will have initial, please don't write anything, initial concentration of reactant, the rate constant of the reaction, and then it is going to have a term that is going to give you the final concentration of reaction, not reaction, reactant, final concentration of reactant, and the time taken to go from initial concentration to the final concentration. Okay, so these are the 4 terms. Questions कैसे आएंगे? 4 term है आपके पास. You will be given 3, and you need to calculate one of this. Linear equation in 1 variable type का सवाल होगा. Now please write integrated rate law expression. Integrated rate law expression. देखिए बच्चों को जो दिक्कत होती है ना, सर ये पता नहीं रहता कौन सा हम फॉर्मूला यूज करें. ध्यान दीजिए, हमने क्या कहा, आप इस पर्टिकुलर एक्सप्रेशन से कभी पता नहीं लगा सकते that how much time is it going to complete the reaction, है ना, इस इक्वेशन से. We cannot say this. Already I hope you understand this, because rate is going to decrease as the concentration is going to decrease. ठीक है, तो rate is ever changing, और rate अगर हमेशा चेंज हो रहा है, then we can never say that कितना टाइम लगेगा पूरे रिएक्शन को कंप्लीट होने में. Okay, so for that we have integrated rate law equation. Please write the first one, zero order reaction. We'll look at the integrated rate law equation for zero order reaction. Please write. In zero order reaction, let us suppose we have constant A, which is going to give you product B. Now the rate law is going to be what? The rate law is going to be the rate of reaction is equal to the rate constant K, concentration of A to the power 0. That means rate is just equal to K. Rate is just equal to K. Also, we can say that note in zero order reaction, rate is always equal to the rate constant. Is always equal to the rate constant. Okay. Now, when we are going to do integration for the rate law expression, we have rate from two different venues. We have rate from the monitoring of the reaction, and then we have the rate law expression. So rate is equal to minus dA upon dt. Also, rate is equal to the concentration of K, right? So concentration of, K into the concentration of A to the power of 0. Or that means we can write it is just equal to what? K. It is just equal to K. That means I can equate both of these things. I can write minus dA upon dt is equal to K. Now we have two different variables. We have the time variable because time is ever changing. And as the time changes, the concentration of A is also going to change. We have, sorry.
So how do we get minus?
Who is asking this? अब्दुल रहमान?
Yes, sir.
नहीं याद है आपको? थोड़ा सा ध्यान दीजिए. ए क्या है बताइए जरा. What is A? Sorry.
Sir, is it due to reactance?
सही सही, हाँ बिल्कुल सही. Okay, now we have two different variables, time and the concentration of A. As the time is going to increase, the concentration of A is going to decrease. Now we have two different variables. Maths वालों को शायद थोड़ा सा कुछ पता हो. There is something which is known as variable separation, right guys? So we'll separate the variables. We'll have minus dA in one side, and we will have K dt in the other side. And now what we are going to do, we are going to integrate on both sides. Please write integrate both sides. So we'll have minus of the integration of dA will be equal to the constant K will be outside, integration of dt. Now, integration is there and we don't have any, we have integration and then just the differentiation. So this will be equal to what? I hope all of you know that. The integration of x to the power 0 dx is equal to how much? It is equal to x, right? That means integration of what? dx is equal to x. यहाँ पे आपके पास क्या आ जाएगा? Minus a plus c होगा because it is indefinite, will be equal to kt plus the integration constant c. Now let us see what is c here. Let us see what is c. Now for c, what we will do at time 0, at time is equal to 0, T will be equal to 0 and the concentration of A will be equal to the initial concentration, and we say that initial concentration is A naught. I think A naught means concentration of A when time is 0. Now when we are going to plug in these things, so A will become minus A naught will be equal to K into the time is equal to 0 plus C. So from here I can write that the C is nothing but negative of initial concentration of the A. Okay, negative of the initial concentration of A. Now we'll plug in this in equation 1. Plug in value of C in equation 1. Someone has sent me a chat. अभी हम नहीं देख रहे, ठीक है ना? Let me just complete it, then I will take your doubts. When I'm going to plug in this in, minus A will be minus A is equal to KT. Now C is equal to what? Minus A naught. I can write this, minus A naught can go there. So initial concentration minus final concentration will be equal to KT. So this is the integrated rate law equation for the zero order reaction. Okay, so this you have to remember, you have to memorize. There is no other way. Zero order reaction के लिए you need to memorize this part. And also you need to understand एक बार, दो बार, तीन बार, पांच बार. Please do the derivation. Derivation has also been asked in the examination. चलिए, there is some. Sir, should we when we are integrating, should there be plus c? नहीं. Constant और constant तो constant ही रहेगा ना. 2x plus 4 is equal to 1y plus 5. तो यहाँ पे अगर हम वेरिएबल सेपरेशन कर रहे हैं तो आप ये लिखिएगा ना इसको 2x is equal to 1y plus 1. समझ में आ रही है बात? एड रियल. So there is only one constant.
Okay,
है ना?
okay.
ठीक है. मैथ्स के इक्वेशन में आपके पास दो अलग कांस्टेंट नहीं हो सकते. कांस्टेंट इन द सेंस कोई दो नंबर नहीं हो सकते हैं. If or also if you are having same units, है ना, these C's are what unitless things, तो उनके पास आपके बस एक ही कांस्टेंट वैल्यू होगा, एक ही टर्म होगा, दो टर्म नहीं होगा उनके लिए. Please write this down. Let me know when you are done. Is there anyone who is still writing? Is there anyone who is still writing? No, no one is writing. All of you understood this? Any doubt in this derivation? Yes or no? Please tell me, guys.